everyone. Hope you all are doing well. Today we'll learn how to divide algebraic expressions. So let's start. In order to divide algebraic expressions, there are some steps that we need to keep in mind. The steps are given below on the screen. First is divide the signs. What do I mean by it? Like if you are dividing two algebraic expressions, say you are dividing 2x with minus 4y. So first, always and always we look for the signs of the algebraic expression. Like 2x doesn't have a sign before it, so it means it is positive. And 4y has a sign, negative sign before it. So first we'll apply the rule that whenever one of the sign is positive and one of the sign is negative, how do we divide them? We'll learn about it in the upcoming slides, but you should get an idea what I mean by dividing the signs, right? Second is we divide the numeric coefficients or the numbers present in the algebraic expression. Like in this case, the numbers are 2 and 4. So second step would always be divide the numbers, whatever numbers are present in your algebraic expressions, divide them. And the third and the last is divide the variables. Whatever variables are present in the algebraic expressions, we divide them. Like there is x and there is y. So we'll divide them. How to divide them, that we'll learn in the upcoming slides. I hope it's clear. So let's learn about it using few examples. Yeah. So here comes the first example. So it says simplify minus 7x over 14y. So basically they are asking us to divide minus 7x with 14y. So please keep those three rules in your head. That first we divide the signs. Here the first algebraic expression is having a negative sign and the one in the denominator is having no sign. It means it is positive. Always and always remember, whenever minus is present even number of times, in case of division also, these rules are same as they were in case of multiplication. You can check the previous video to get to know those rules. If minus is present even number of times, when you are dividing or multiplying algebraic expression, answer would always be positive. If minus is present odd number of times in the algebraic expressions you are dividing, then your answer would be having a negative sign. I repeat, if minus is there odd number of times, like 1 time, 3 time, 5 time, like count all the negative signs. If it is odd, answer would be negative. If minus is present even number of times, then answer would be positive, right? So in this case, minus is present only in one of the algebraic expressions. So we can say in the entire quotient that we have to solve, minus is present odd number of times. That's why in our answer there would be a negative sign. Clear? Now, according to the rules, second step is we need to divide the numeric coefficients or the numbers, right? How do we divide the numbers? Like there is 7 and there is 14. So we will divide them. If we can simplify them, we will do it. So 7 times 1 is 7 and 7 times 2 is 14. That's how we got 1 over 2, right? So that is from where we are getting 1 over 2. At the last, we will divide the variables. There is a x, there is a y. We need to learn how do we divide variables in such a case when the variables are different. So about it, the information is provided on the left of the slide, that if variables are different, if the variables are different in case of division, they remain at their places. Means x would remain in the numerator at its place, like in the answer we have written, and y would remain at its place in the denominator. That's how we are getting the answer as minus 1x over 2y. But as we know, minus 1x means 1 times x. And any number multiplied with 1 is the number itself. Similarly, 1 times x is x only. That's how we are getting minus x over 2y as our final answer. I hope it's clear. Now, let's look at another example to learn a new something new, which is how do we solve for variables? How do we divide the variables when the variables are same? In the previous case, the variables were different. There was x and there was y. How will we solve such questions wherein the variables are same? So let's have a look. The question says simplify 36p square q over 2pq. Following the rules, the three rules. First divide the signs. Since both the numbers, both the algebraic expression that we are dividing doesn't have any sign before it, so basically it's a positive sign before both of them. We know plus divided by with a plus is a plus only. That's how the final answer is having a positive sign. No sign means positive sign. Next we'll divide the numbers. So 36 divided by 2, we know that it's 18. That's how we are getting 18. Now the new thing is how we will solve for the variables. First thing, the variables are same. Second thing, there is more than one variable. So how are we going to solve it? So the rule is written on the left side. If variables are same or the bases are same, powers get subtracted. What do we mean by it? Let's first choose the variable for which we want to solve first. Since there are two variables p and q, let's suppose we are solving for p first. But as you can see, there is p in the numerator also and there is p as variable in the denominator also. It's written if variables are same. In case of division, we can say, okay, p square in p square, p is the base, okay, and square, that power 2 is the power, okay. P is the base and 2 is the power. So if variables are same or if bases are same, powers get subtracted. So what will happen over here? Always remember, we try to solve these powers. We try to apply these rules generally in the numerator only. Means I'll keep the p as it is in the numerator only and apply the rule. There is a power 2 and the power in the denominator is p raised to power 1. So it's 2 minus 1. Generally we solve it in the numerator only. So basically we are getting 18, and then for this p we solved in the numerator, we get p raised to power 2 minus 1, which is p raised to power 1 only, right? But suppose in a case if a greater power is in the denominator, then we'll solve in the denominator. Let's consider an example. Suppose you're having q over q cube. Then in that case, we'll apply this rule in the denominator. How? So q will remain over here, base same, power subtract. So 3 as it is. This 1, now this 1 is coming from numerator to denominator. That's why it would be minus 1. Applying the same rule, if variables are same in division, powers get subtracted. So basically we always tend to subtract the smaller power from the greater power. Are you getting it? So our final answer would be 1 over q square, because 3 minus 1 is 2, right? Okay. Now let's continue with the question that we were discussing. So we solved for p and we get 18 multiplied with p raised to power 1. But there is one more variable which is q. So let's solve for it. Since q has same power in numerator and denominator, you can solve it either way. Up to you. I am solving it in the numerator only. So it's q raised to power, there is no power of q, it means there is 1. So q raised to power 1 in the numerator, q raised to power 1 in the denominator. So 1 minus 1 is 0. So we are getting q raised to power 0. Okay. So our answer is 18, p raised to power 1, q raised to power 0. But why I have written the answer as 18p only? Please focus over here. Like you must be aware about this thing that x square means x is getting multiplied 2 times, right? So can I say x raised to x just means x is there one time? It means x raised to power 1 means just 1x, as x square means 2x. 2 times x, x multiplied by x. X cube means x is multiplied 3 times with itself. So x raised to power 1 means just x. It means if there is no x, can I write x raised to power 0? If x raised to power 1 means x is written one time, it means x raised to power 0 means x is not written any time, right? So basically just a number 1 I can say, right? So from there only the rule says anything raised to power 0. It could be a variable, it could be a number. Anything which has a power 0 would always be equal to just 1, because that thing doesn't exist. That's why the power is 0. I hope it's clear, right? So p raised to power, as we have done over here, something raised to power 1 is the number itself. So p raised to power 1 is p only. But q raised to power 0, as we learnt over here, something raised to power 0 is 1. So basically it's 18p multiplied with 1, which is 18p only. I hope it's clear to you. Now let's move to the next example to understand things better. Okay. So the next example says, simplify 7x square multiplied with minus 2x multiplied with 48y cube divided by 8x multiplied by 28y raised to power 4. So the question is of similar kind. It's just that there is more than one algebraic expression. Earlier there was just one algebraic expression in the numerator and one algebraic expression in the denominator. But here there is more than one algebraic expression present. So how will we solve? No need to worry. Just keep those three rules in your head. Count the total number of negative signs. There is just one sign, negative. It means in your answer there would be a minus sign, right? Now solve for the numbers present in your question. So there is 7. Bracket always means multiplication. So there is 7 multiplied with 2 multiplied with 48, right? We will always solve for the numbers, especially in the beginning. If you are doing it for the first time, maybe you are in 7th grade or 8th grade, please do follow these steps. And in the denominator there is 8 and there is 28. Cancel those numbers which you can cancel. Okay. So as we know, 8 times 1 is 8 and 8 times 6 is 48. Right. Similarly, 7 times 1 is 7 and 7 times 4 is 28. Now 2 times 1 is 2 and 2 times 2 is 4. Right. And 2 times 1 is 2 and 2 times 3 is 6. So in the numerator we are left with just 3. 1 times 3, which is 3 only, right? In the denominator there is no number left. 1 times 1 is 1 only. That's how after solving for the numbers we are left with just minus 3. Now let's solve for the variables. First of all, focus on how many variables are present in total. There is x, there is y. So there are two variables. You can solve for any variable on the first attempt. Totally up to you. I'm starting with x. So there is x. Here we need to apply the rules for multiplication. Bases are same, powers get what we do in case of multiplication and what we do in case of division. We need to keep both things in our head because x is there in multiplication with x also and there is x in division also. You can solve it either way. Okay, let's see how we can do. I can either do multiplying x square with x. So as we know, if I am multiplying x square with x, basically I'll apply that rule. If bases are same, since x and x are same, powers get added. There is no power, it means there is 1. So 2 plus 1 is 3. I have solved for just those x which were in numerator. I got x cube. Now there is 1x in the denominator. So basically we are dividing with x raised to power 1. I can write x raised to power 1 over here. Now applying the rule for division, which says if bases are same, x is the base over here, x is the base over here. Powers get subtracted and we normally tend to subtract the smaller power from the bigger power. So 3 minus 1 we get 2. Right? So final answer we are getting x squared, right? But there is one more way of solving it. How? Let's see. Okay. So instead of multiplying first then dividing, I can solve it directly also. How? Just write down the x variable somewhere in your rough sheet so that you can focus. So there is x square multiplied with x and there is x in the denominator. Always remember, you can simply cancel those x, like 2 and 2 get cancelled with each other, right? Similarly, x and x can get cancelled directly. How? Basically this x that I have cancelled from numerator was having a power 1. Similarly, x in the denominator was having a power 1. So I solved for them. Bases same, powers get subtracted. So 1 minus 1 is 0. Something raised to power 0 is always 1. That's how they get cancelled and we get just 1. And x square times 1 is x square. We are getting the same answer. So it's up to you how you want to solve it. We can always cancel those variables directly with each other which are having the same powers. I hope it's clear that we'll get x square when we solve for x in the numerator and the denominator. Right? Okay, now So we got x square. Let's write it over here. Now let's solve for y. Again, there is y cube and there is y raised to power 4. As I told you, we generally tend to subtract the smaller power from the bigger power. So y cube divided by y4. There would be nothing in the numerator. It's basically 1 because the power has been shifted from the numerator to the denominator. So 4 minus 3, which is 1. So y raised to 1 we are getting, and y raised to anything raised to power 1 is that number itself, that variable itself. So that's how we are getting minus 3x square over y. I hope it's clear. Is there any doubt or something? If there is any, you can always ask in the comment box. So let's move to the next question, the last question, which is a little more complicated than the earlier ones, but we'll just keep the 3 rules in our head, nothing more than that, and we'll be able to solve it. So it says divide minus 49 p square q cube r, this is a fraction, over 26 p4 by 14 p6 qr raised to power 7 divided over minus 13 pqr. So first, since there is division, so I'm replacing dividing the by with the division sign, right? As we know, fractions we can't directly divide, so we'll follow the rule that this division first fraction would remain as it is. Okay, this division sign will turn into a multiplication and we swap. Swap means the numerator and denominator would be interchanged with each other. The second fraction would be swapped. So whatever was the numerator of the second fraction earlier, now it will become the denominator, and whatever was the denominator of the second fraction earlier, it would become the numerator. I hope it's clear. This is how we normally solve the normal fractions also, which doesn't include any variables. Similar pattern we are doing. Now, applying the rules that we studied, from here we'll start. Count the total number of minus signs. So minus is present even number of times, 1 and 1, which is 2. So answer would be positive. Or you can simply say minus get cancelled with minus, that is also fine. Right? So that's how answer is positive. Now we'll solve for the numbers. So there is 49 divided by 26 multiplied with 13 over 14, right? Okay, so as we know, 7 times 7 is 49 and 7 times 2 is 14. So we solved it. Similarly, 13 times 1 is 13. 13 times 2 is 26. Nothing more could be cancelled, nothing more could be simplified. So we'll simply multiply the numerator with the numerator and denominator with the denominator. So 7 ones are 7 and 2 times 2 is 4. That's how we got 7 over 4. Right? Now we'll solve for the variables. But before starting with it, please focus on how many variables are there. There is P, there is Q, there is R. So there are 3 variables. You can solve for any one as per your choice in the first go. I'll go in the alphabetical order. So that's why I'm choosing P. There is P squared. There is P. So basically I can say if I apply the rules of multiplication, if variable bases are same, if the variables are same, powers get added. So we have 2 plus 1, which is 3. So there is a P cube in the numerator, and there is similarly P4 and P6. Again, these two are in multiplication in the denominator. So base same powers get added. So P raised to power 4 plus 6, which is 10. So this is the last thing we need to solve. As we have learnt, we tend to subtract the smaller power from the bigger power. So P, the bigger power, wherever the bigger power is, the variable would remain there, and we'll apply the operation, which is base same powers get subtracted. So 10 minus 3, which is 7. And since there is nothing in the numerator, so it would be 1. So basically we are getting P raised to power 7 in the denominator. Right? I hope it's clear. Now similar way we'll try to solve for q. Okay, let's do it directly like we did in the previous one. There is q raised to power 1, there is q raised to power 1. They get cancelled with each other. There is no more q over here. Over here there is just q. No q over here. So q would remain q, right? Now solving for r. Okay, let's see if we can directly cancel something. Okay, we can't, so we'll do it properly. R raised to power 1 multiplied with r raised to power 1. So it would be r square in the numerator, and there is r raised to power 7 in the denominator. Again, since bigger power is in the denominator, so variable would remain there in the denominator and power would get subtracted. So 7 minus 2, which is 5. So basically we are getting r raised to power 5 in the denominator. That's how our final answer is 7q cube over 4p7 r raised to power 5. I hope it's clear to you. If there is anything that you are not clear with, you can always ask in the comment section. Let's move to the next slide now. So that was all in today's video. Thank you for your time. And in the next video, we'll learn how to multiply and divide binomials and trinomials. I hope you are aware about what binomials and trinomials are. Okay, even if you are not aware about it, you can always go and watch the previous videos. That they consist of these terms, binomials and trinomials. You'll get to know what they are. In the description of each and every video, it's quite like it's explained what the video is about. So you can accordingly watch the video wherein you can find binomials and trinomials. Once again, thank you for your time, and if you find the video useful for you, then please do like and subscribe to the channel.